ngezilokotho ezinhle Ithala kanye neGo Digital SA Foundation. Thamelani izifundo ze-mathematics, i-accounting, isiZulu ulimi lwasekhaya, isiNgisi, i-FAL, i-physical science, i-geography, ezobuchwepheshe, i-computer applications technology kanye namaklasi e-learner wellness okungukuzilolonga ngokomqondo kanye nomzimba. Lezi zifundo zethulwa nsuku zonke kusukela ngoMsombuluko kuya ngoLwesihlanu kuqala ngehora lesi-4 kuya kwelesihlanu u-4 kuya ku-5 ntambama nangoMgqibelo kusukela ligamanxe ihora lesi-8 8:30 kuze kugamanxe ihora lokuqala emini 1:30. Zithameleni futhi lezi zifundo emsakazweni Ukhozi FM njalo ngoLwesine kusukela ngo-9 kuya ku-10 ebusuku. Ningangena ekhasini lethu lika-Facebook elithi Go Digital SA_movement noma kwi-YouTube uthi Go Digital SA Foundation. Siyethemba nizolijabulela lolu hlelo oluhlose ukunifundisa futhi lulekelele kulokho enikufunda ezikoleni zenu. Luthokozeleni-ke lolu hlelo nimeme nabo bonke abanye abafundi bebanga le-12 grade 12 ukuze nabo bazuze kulo futhi nonke nicijeleke ukuphumelela kwizivivinyo zenu zokuphela konyaka.
Sanibonani bafundi, sawu Mr. Mbayi lona, so khuluma nge-electrodynamics namhlanje. Last week sasikhuluma ngama-electric circuit, sesiyaqhubeka nje naleyo topic ethi electricity and magnetism. Namhlanje sidila ne-electrodynamics. Le-electrodynamics kumele ngabe niqale ka grade 10 nikhuluma nge-magnetism. And mangikhuluma nge-magnetism niyazi ukuthi magnet ina north pole ne-south pole kunama lines of field, right? Lines of field that move from north to south. Then ka grade 11 nakhuluma nge-electromagnetism. Electromagnetism nanihlanganisa ukuthi intambo kagesi makuno electricity ehamba kuyona there will be i-magnet. Leyo ntambo lizobehave as i-magnet kusho ukuthi kuzoba i-magnetic field around it. Nayibiza ngani current carrying conductor. So mona electric conductor khona electricity or current ehamba kuleyo conductor, then your conductor is over like a magnet, so around it there will be a magnet. Meseke kuba nokuthi mawunyakazisa i-conductor through i-magnetic field noma i-conductor ihambe through changing magnetic field, ikhona i-current that will be induced. Ngamanye amazwi i-current yakwazi ukunikela i-magnet, at the same time i-changing magnetic field nayo ngakukhiphela bani ugesi, ngakukhiphela i-current. So those are the two principles that esebenzisa ku-electrodynamics. I said ukuthi mauna conductor, electric conductor, then ufaka electric current, that conductor will behave as a magnet kusho ukuthi i-current iproducer i-magnet. Kodwa ke futhi maune changing magnetic field mase kuba ne-conductor, there will be a current that will be induced in that particular conductor, right? So nafunda nge Faraday's law. Faraday's law lokhuluma ngokuthi i-magnetic field izo inducer i-current, so kunika i-magnitude yaleyo current. Sasicalculate EMF, the EMF that is produced across the conductor up to a formula ethi negative N delta phi over delta T. Ukuthi Faraday's law ethi the electromagnetic force, electromotive force induced in a conductor is directly proportional to the rate of change of the magnetic flux. Delta phi magnetic flux. Ngiyazi ukuthi last year ka grade 11 anwenzanga ama calculations, but ke ayabuya ka grade 12, right? So into sifanele simone ukuthi i-application yalo Faraday's law uzoba njani-ke in terms of electrodynamics. Lana sikhuluma ngama-electric machines. That so sibuka i-application ye-Faraday's law ne-application yabani current carrying conductor. Now, into efanele siyazi ukuthi we need intambo, that's an electric conductor. So if we have a conductor, sidinga a current, electric current, then sidinga a magnet. These are the three main things esoyidinga, right? Now, masibuki conductor kwenzekalani kwi-conductor. I-conductor can move kusho ukuthi yona inganyakaza isukela izela, then kusho ukuthi isinika any emotion. So we have three quantities. Koni magnet izokusinika i-magnetic field, kune current, electric current, siphinde sibe ne-conductor. I-conductor, i-current izohamba through i-conductor. Le conductor mawuthi ihlele phakathi kwe-magnetic field, koni current izo-induceka kuyona. Then le conductor is njengoba inyakaza, then isinika ini emotion. So sinama quantities out to emotion in a direction, ingasuka left a right, current same thing, ne magnet nakhona sina ni magnetic field. I-magnetic field siyazi ukuthi khona direction njengoba nafunda grade 10 ukuthi isuka from north pole ya ku south pole. So yonke into esinayo lana in a direction, right? So asibukeke in terms of electric machines. So khuluma ngama electric machines. This is the application of Faraday's law. Electric machines, the simple electric machines. Asithathe ngokuthi mhlambe sine magnet. Asa magnet emi kanje like a U-shape magnet, right? Siyazi ukuthi makune north no south, ama lines of field asuka from north aya ku south. Njengoba siyazi ukuthi lines of field will have a certain direction, right? Mesele sifaka i-conductor, right? So faka i-conductor nanti electric conductor inje, right? Now akwenzeki lutho makunjena ngoba sine conductor kuphela, then sinani ne magnet, akwenzeki lutho. Manje kufanele sibe nani ne input ukuthi yini lesifanele siyenza ngoba nothing is connected to the conductor. Then sibambe le end nale ngala sifake mhlambe i-battery. Uma sesifaka i-battery, what will happen? Sekuzoba i-current. I-current izongena la, izohamba ihambe kule conductor. Into siyaziyo futhi from grade 11 ukuthi makhona i-current ihamba through a conductor. Le conductor le izobehave as a magnet. Kusho ukuthi across this conductor kuzo produceka a magnetic field. So there will be a magnetic field across around this conductor. Angithi le conductor is between within a magnet. Le magnet now in a magnetic field. So sinama magnetic field out too. Into sokumbula grade 10 says ukuthi like poles will repel and unlike poles will attract. So le conductor behave njenge magnet, kusho ukuthi khona magnetic field. Mase kuba khona le magnetic field ye magnet esinayo la. So the two magnetic field will interact. Mase ku interact kuzoba either attraction noma repulsion. Kuzokwenzekalani? The conductor le izohamba mhlambe imove to the right noma ihambe to the left. Right, i-principle yokuqala ke le. Uyabona ukuthi sifake i-current, sifake ugesi, i-current, safaka u-current, i-current yasinika any emotion, le conductor siyanyakaza. But before sifake i-battery, nothing happened. So kusho ukuthi lana uzobona ke mawufaka i-current isinika emotion. Kahle singathi ukuthi emotion we can express it as mechanical energy. Kanti i-battery lana izosinika bani electrical energy. That is the first principle. Le principle siyibiza ngani? Siyibiza nge motor effect. Motor effect. Right. Now, this is a machine, an electric machine that convert electrical energy into mechanical energy. So masicisha ugesi lana, like mhlambe sino switch la, this switch masithi i-off, le ntambo izoma nayo. But once we connect it, there is a current flowing, then the conductor will move, right? So singathini, input yetu, input sine magnetic field, ile magnetic field ye magnet plus sifake i-current, nanti battery yethu la sinikwe current, sithola uthini, sithola i-motion, right? So kashari soti, we converted, right, electrical energy is converted to a mechanical energy. Mechanical energy ngoba kuyanyagaza. A mechanical energy, right? This electric machine ezoshintsha electrical energy into mechanical energy siyibiza ngani? Ngemoto, right? So we have a motor, right? That is a motor. Mawubuza ukuthi imoto isebenzisa which principle? Principle yakhe bani? I-motor effect, right? Kusho ukuthi ufaka i-current ikunika bani? I-motion. That is the first machine esokhuluma ngayo, right? An electric machine called the motor, electric motor, right? Now lana sibona ukuthi siyakwazi ukusebenzisa i-current ukuze sithole i-motion of the conductor, right? What if sishintsha-ke this time sibe naleyo magnet, asibukeke enye indlela singayisebenzisa le conductor, the same magnet, asibe futhi ne same magnet, a U-shape magnet, into siyazi ukuthi khona ama lines of field asuka from north aya ku south, right? We have that one. Then again sibe nale conductor yethu, ila, right? But this time asifaki lutho as i-battery, kodwa mfanele into siyenzayo sivele siyinyakaziseke le conductor, either siyisanga left noma siyisanga right. Then it was seen ukuthi njengoba le conductor ihamba through i-magnetic field, kusho ukuthi ne strength of a magnetic field iyashintsha ngoba vele ayifani i-magnetic field strength ela nale la, for example. So as it's moving, isibuyisela kubani? Ku Faraday's law. When there is a change in the magnetic field, a current will be induced. So kuyatholakala ukuthi mawunyakazisa le conductor, at the end kule conductor khona i-current izo-induseka, kule conductor. So njengoba sine current kusho ukuthi siyakwazi uconnecta ke something, into efana mhlambe ne bulb, i-globe, right? Then this one yabona ukuthi input yethu besifake eni i-conductor sayinyakazisa ke, masiyinyakazisa, that is a mechanical energy that we put in, right? Mase kufika indlela ukuthi i-current i-induced, this one goes with Faraday's law, sizothi ibizwa ngani? I-electromagnetic induction, right? This is the principle used kule mshini, electromagnetic induction. Senze njani futhi? Simona ukuthi besina magnet like the first one, sina magnet noma magnetic field, mese safaka emotion. This time sifake emotion, sathola i-current, so a machine mbona ukuthi sifake emotion, and emotion representa a mechanical energy. Kusho ukuthi lo machine wethu uconverta i-mechanical energy to electrical energy ngoba isinika bani? Current. So we have a machine that converts mechanical energy to electrical energy. Leyo machine lo converter mechanical energy into electrical energy, so ibiza ngani nge-generator. So this one is a generator. Mawubuza ukuthi i-generator isebenzisa which principle? I-principle yakhe ubani? Electromagnetic induction. So those are the two machines esizokhuluma ngawo. Right. Now the first one sithe isebenzisa i-motor effects. Sifaka i-current, sithola i-motion, but through i-magnetic field. The second one sikhuluma ngani nge electromagnetic induction. So that one sifaka emotion, sithola bani i-current. So that becomes what? I-generator. So sokhuluma ngale machine u2 i-generator ne sokhuluma nge-generator siphinde sikhulume ngemoto. Kodwa uyabona ukuthi umshini owodwa uyakwazi ukwenza imisebenzi o2. It's up to you. So i-setup yakho kuya depend ukuthi yini oyifakayo between emotion ne current. Mawufaka emotion uthola i-current, mawufaka i-current uthola emotion, right? So kusho ukuthi mawufaka i-electrical energy uthola mechanical energy. Leyo nto nika bani imoto, right? And i-principle yakhona it's a motor effect. Kodwa mawufaka i-current, mawufaka i-motion kusho ukuthi unyakazisa leyo ntambo le through i-magnetic field, then ukhiphela bani? Ukhiphela i-current. Khona i-current izo-induseka kule conductor. So that is the electromagnetic induction. Leyo sisebenzisa for i-generator, right? So into fanele uyazi ke those the difference between the two. Siyazi ukuthi masine generator for each generator si converter mechanical energy to electrical energy. Then the motor si converter electrical energy into mechanical energy. Then in terms of principles, a generator isebenzisa electromagnetic induction. Kanti imoto isebenzisa imotor effect, electromagnetic induction. Bese kuba imoto yona isebenzisa imotor effect. Right? Those are the two principles sizoba now. Then into sibona ukuthi vele i-setup into eyodwa kusho ukuthi an electric machine can work as a generator, iphinde isebenze futhi as imoto. Kuya depend ukuthi wena ini input yakho. Uma ukuthi input yakho i-current izokunika emotion. Right? Then a setup that will be easy. Uyabona ukuthi le ndlela ngiyisethe eqala, uyabona ukuthi inama limitation ngoba makunyakaza le ntambo ingaphuma outside of a magnetic field. Yabo akusasiniki into esifunayo. So at the end ama scientists nama engineers cabanga indlela ukuthi ezasiza ukuthi kube ne continuation. Makuthi kuyanyakaza kube ne continuation. And the circular shape or cylindrical shape was the correct one. Yabona, that's why uzobona most of ama motor noma ama machine tesinawo, right? They have this shape. Ukuthi makunentambo la iyakwazi kunyakaza like clockwise noma anti-clockwise. So they will never be what? An end, right? So so that is how we look at electromagnetism, right? Then uthola kanjani i-direction of rotation noma i-direction ye-current? Ngoba lama quantities esikhuluma ngawo khona magnetic field siyazi ukuthi move from north to south, kube khona nani ne i-current. Now yakwazi ukumove from one point of a conductor to another point of a conductor. Siphinde tube nani ne-motion. Njengoba sine shape enje kusho ukuthi sokhuluma ngani i-conductor ingamuva clockwise noma imove anti-clockwise, right? So into esifanele sibone ukuthi mase kunyakaza i-conductor kuzoba nokuthi i-current izoba induced noma noma mawunyakazisa i-conductor i-current izoba induced noma mawufaka i-current i-conductor izonyakaza. So imoto for example indaba yamafeni nani ekhaya uyabona ukuthi ifeni ya rotate angithi uyayiplug, by the time uyiplug that is the electric current oyifakayo, then leyo electric current izosebenzisa i-motor effect bese iya rotate, right? For kuyi-generator kumele ube nendlela uzonyakazisa ke leyo conductor. Sometimes kusetshenziswa i-engine, right, that will make the motor to rotate bese kuphela bani kuphela ugesi, that becomes a generator, right? I-direction uyithola with your hand. Yabosebenzisa iminwe nje the three fingers, right? You have the middle finger, the index as well as the thumb. So ufanele umise in a way ukuthi kwenza u-90 degrees with each other. Angithi sikhuluma nge-motion, sikhuluma nge-current, siphinde sikhulume nge-magnetic field. So i-index yakho izorepresenta i-direction ye-magnetic field. Kusho ukuthi i-magnetic field ihamba ngala. U-north wakho ngala, u-south, ngoba siyazi ukuthi i-magnetic field move from north to south. Mese kuba nale isitupa sikhombisa bani i-direction of motion. Kuti conductor izosuka ngala ihambe ngala, right? Then the middle finger represent what? I-current, i-direction of the current, right? Asithi kuyibuka ke mhlambe nge-diagram mhlambe so understand ukuthi isithini la. Right, this is a simple machine. Uyabona kuno north, kuno south, then nathi conductor, right? Sifaka between a magnet. Now into siyaziyo ukuthi the two magnets khona ama-lines of field asuka from north kuya south, asuka from north to south, right? Then i-current fanele nayo ibe ne-direction, isuka ngala ishone ngale noma ibuya ngala. So i-direction ye-current sinayo. At the end futhi leyo conductor ifanele inyakaze, kungamove either clockwise noma anti-clockwise. Those are the three quantities ifanele sikhulume ngazo, right? Now mawusebenzisa imoto uzosebenzisa your left hand, kodwa the fingers they still mean the same thing. Motion lena, direction of magnetic field, and this one is the current, right? Mawusebenzisa generator uzosebenzisa your right hand, still same thing. Motion lena, direction of a magnetic field from north to south, mese upinda ube nani ne current, right? Now in our example, for this drawing here, this picture, and so yabona kune battery. So awudingi nokusho ukuthi is this a motor or a generator. As long as subona battery kusho ukuthi this one is a motor ngoba ikunika electrical energy. So uyibona kanjalo ukuthi lo machine lo it is a motor noma a generator. Makuyi motor uzovela ubone nge-battery like kwi-example yethu la. Excuse, i-battery. Then sibona kanjani i-direction ke ukuthi le motor izo rotate kanjani. Kusho ukuthi ngoba kuyi-motor sisebenzisa the left hand, njengoba sishilo ukuthi for a motor sebenzisa left hand, and for a generator sebenzisa right hand, right? But the fingers they still mean the same thing, the right hand, right? Now I start an example. Let's say this terminal of the battery is positive. Mawuthi positive kusho ukuthi i-current izohamba kanje, right? Ifike la nanti intambo. Now how ubona kanjani ukuthi izo rotate clockwise noma anti-clockwise? So sebenzisa yo left hand. Now kule diagram yami ngifuna ukwenza the same thing. Angisibona unorth ungala usouth. This finger here is the one ekhombisa i-direction, right? Ye magnetic field from north to south. Mese ngibuka to i-current, right? I-current isuka la ishona le. So ngizokwenza kanje i-current. This one shows a direction. North is on my left, south is on my right. So ikhomba ngala. the middle finger shows the current. Yabona ukuthi current move away from me. Then the thumb here shows downward. Kusho ukuthi lento izoya downward in that case. So makuthi this part of the machine goes downward, kusho ukuthi sinani sine rotation is over anti-clockwise intention. That's how you find the direction. Maku generator wenza njani? Vela ngeke ubone battery, uzobona hlambe I globe noma ubone galvanometer noma voltmeter, anything esebenzisa ugesi, then you know ukuthi no, this one is a generator. So you can easily identify ukuthi this machine is a motor. Just look at the setup. Kune battery, it's a motor. Maubona ukuthi globe or there is a voltmeter, then that one is a generator. Ngiyathemba ukuthi siyazwana. Right. Now, asibukeke I-current the types of machines that see now. Right, an electric machine kahle ngaphakathi kuhlezi ukukhiphela bani I-current enyakazayo alternatively. Right? Masibuka le conduct angithi iseduze kwa north. Then by the time I-rotator ingathi iya away from the north, kusho ukuthi ne magnetic field strength iya decrease. Mak decrease kusho ukuthi ne current through le conductor iya decrease. Mase kufika la uzobona ukuthi le conductor by the time isephenduka izozangala on the south pole. Maku south pole I-current izoshintsha, then izoshintsha direction. So at the end uzothola ukuthi I-graph yakho izokunika into ukuthi iqala maximum makuthi imile ngale ndlela le, this is the maximum position. So as it rotates, I-current iya decrease is over 0 by the time I-conductor is perpendicular to the lines of field. Mase iyanga on the south pole ishintsha direction. So at the end uzothola I-graph enje. Then we say this is an alternating current. Alternating current. Yeah, alternator. Alternating current. Right. Lento enzeka phakathi komshini. Then if we have a generator, sobona kanjani ukuthi into isothola outside I-outputs, kungenzeka ukuthi sikhiphe I-outputs ezoba alternating noma izosinika into izoba no one side of rotation. Then izosinika ama type to wale machine esikhuluma ngawo. Then we'll have a DC generator. Masikhuluma ngama generator. So bane DC generator sibe ne AC generator. Right. Ini kwenza ukuthi ubone ukuthi une DC generator uzobona ngani ngecommutator. Kwanto sibiza ngecommutator. Right. AC uzobona ngama slip rings. Slip rings. Right. Now let's have two diagrams ezosikhombisa the difference between the two. Right. Now we have two diagrams here, or two pictures. The first one, yabona ukuthi I-setup iyafana, but this one in a split ring. Njengoba split ring, it's just a ring that was split into two. Right? Mawubona ama split ring commutator, that means it's a DC generator or DC motor. Mawubona ama slip rings, there will be two. Kuna ama rings out two. Then that will be an alternating AC, an AC generator noma imoto. Right? Now, mase rotator kona le part le ezosiza ukuthi rotate umshini outside on the output kube nento enganyakazi, but iyakwazi ukusiconnectela electrically from le conductor to the coil and the outside. Sibiza ngama brush. So these two are brushes. Ngisho with DC you still also have brushes. So these brushes, they are not connected, right? So they can slide on this commutator. Commutator le nigabani DC. This will be slip rings. That will be AC. So that's how you differentiate the machines. So sinani, a machine can be a motor or a generator. Secondly, a machine can be AC or a DC. Right. When it's a motor ubona nge-battery, when it's a generator ubona nge-globe noma i-voltmeter. When it's an AC, so kungaba AC motor noma ube AC generator, noma kube DC motor kuphinde kube ne-DC generator. So ubona kanjani ukuthi an AC machine? Uzobona ngokuthi kunama slip rings awu-2, right? Ama-ring awu-2, that becomes a structure ezokwenza ubone ukuthi no, this is an AC machine. Makuna split ring, it's just like a ring that is divided into two. The word said split ring, a commutator, right? That becomes what? A DC machine, right? So ilokho ke ifanele sikwazi. Then the output, mawukuthi sikhuluma nge-generator for example, output ye-AC generator ima kanje. So i-voltage yakhona noma i-current yakhona iya-alternate, iyashintsha ama-directions. It can be current noma i-voltage. Kodwa kwi-DC generator sithola i-output enje, right? Akushintshe, iya-increase i-decrease kodwa ayishintshe i-direction. So that is the difference. In case ubuka into enjena, then you know that is an AC, right? Because of the alternating graph that we have. Then DC, ubona ngokuthi it's only on one side of the graph, right? So this becomes what? A DC machine, a DC generator, right? Then the next thing first sikhulume ngayo will be AC. Ka grade 10 banikhuluma nge-electric current, electric circuit. Then nakhuluma ngo banisebenzisa ama-battery most of the time, right? This time ka grade 12 sesifuna ukusebenzisa AC current, right? We have AC, right? Mawune electric circuit ka grade 10 kwakufaka nje a cell, so uyazi ukuthi this cell have an EMF mhlambe ka 9 volt, ihlezi 9 volt, right? It won't change. But nenkinga ke mosebenzisa alternator, AC generator, ngoba i-current yakhona ayikho stable, iyashintsha every time. So mawukuthi uzoconnecta this kind of source kwi-battery noma kwi-resistor, how do you do the calculations? Sesikhuluma ngani nge-AC, right? I-value ifanele usebenzise, right? Because we have now to look at an example. Let's say ngine source of electric current, right? This time ngizoidweba kanje ngithi nanti generator yethu, then sinani sine resistor la ka mhlambe let's say 24 volt, then connected, right? Now what is the voltage that will be used for load 24? Let's say sidweba ke i-graph ye volts versus time ngala, then isinika le part. Let's say mhlambe sina 12. This is 12 volt. Le part le ikunika bani i-maximum value. Angisho ukuthi akukho 12 every time. So asikwazi kusho ukuthi this source here isinika 12 volt ngoba lo 12 uyabona ukuthi usuka ku0 inyuke ifike ku12, then yehle futhi kuyele ku0 ishinje ku negative 12, 0, positive 12, 0, negative 12. So iyashintsha kahle, it's not stable, it's not steady. Manje ke sifuna ukubona ukuthi which current that will flow through this resistor, right? So i-current i-voltage esoyisebenzisa sibiza ngani nge-VRMS. VRMS. RMS it means stand for root mean square. Root mean square. That's the meaning of RMS. In RMS by definition is the AC value that will dissipate the same energy as the DC. Angithi with DC beso vele bekuzobalula in a setup like this. So tinali battery na 12 volts, right? Nanti i-resistor inabani 24 ohms, right? 24 ohms. So siyazi ukuthi singa calculator i-energy ngala, calculate i-current and so on, sebenzisa bani u-24 u-12 ngoba lo 12 vele ukhona awushintshi. But on this one it's not the 12 volt represent the maximum value. So masifuna ukuthola i-current ihamba ngala asisebenzisi lo maximum value, sebenzisa bani RMS value, right? So by definition we say that is the AC value that will dissipate the same amount of energy as a DC. Manje calculate kanjani le RMS value, because sibona ukuthi sino V maximum at this point, so biza ngani V maximum. V maximum wethu ubani u12 volt. Bese sifuna V RMS. V RMS we calculate from the V max. It's V max over square root of 2. Calculate V RMS kanjalo. So in our case, the maximum value is 12, then it's divided by square root of 2. Then our V RMS will simply be static calculator, 12 divided by square root of 2. Kusinika bani 8,49. 8,49 volt. This is the voltage uzosebenzisa, 8,49 volt. Right. The same thing happens to the current. So ngaba the same graph efana nale, then instead of voltage bakhulume ngani nge-current. So the value ozoyifunda la kwi-graph it's a maximum value. Awukwazi ukuyisebenzisa leyo value mawenza ama calculations. Kusho ukuthi lana masifuna ukuthola i-current sizosebenzisa uVRMS. Asikwazi ukusebenzisa lo 12. So sebenzisa lo 8,49 esimtholile la as calculator VRMS. Then ama formula acisha afane nawa Ohm's law. Isakhumbula lama formula athi I is equal to V over R, current, voltage, ne resistance, and so power is equal to V times I, normal power is equal to V squared over R, normal power is equal to I squared times R. Wonke lama formula asasebenza. The only difference ukuthi mawusebenzisa AC ufanele ukhulume ngani nge-IRMS. So u-add RMS lana kuphela, RMS awuthinti resistance kodwa. So V uV RMS, u-I RMS. Makuno V ufaka RMS, makuno I ufaka RMS. And how do you get that? We are calculator from a maximum value also ithola, right? So the same formula 107 is under Ohm's law. They are the same formula abuya. The only difference ukuthi i-power yakhona sesiyibiza ngani nge-average power ngoba yona iyashintsha. It's just the average that you calculate. Kodwa i-current usebenzisa I-RMS awusebenzisa I maximum, right? So you'll have different calculations abazokutshela ukuthi no, calculate what is the current. So in our example here, right, we have this source of the energy, electrical energy, and no 12 volt maximum value. Then to calculate the current through the 24 ohms resistor. So the first thing is calculator UV RMS, right? It's calculator UV RMS. Must calculate UV RMS simtolile solubani 8,49. So njengoba sino 8,49 siyakwazi ucalculate abani i-current. Siyazi ukuthi i-current IRMS will be equal to VRMS over R. So in that case, so bani 8,49 over 24. So IRMS yetu will be 8,49 divided by 24. So 0,35 amps, right? This is the IRMS. So mokutiwa dweba age I graph ye current versus time. Yabona ukuthi I graph idinga bani? Idinga maximum value. Kodwa le value si calculate la I RMS value. So siyakwazi futhi ukubuyela kwi maximum. Masina RMS siyakwazi ukubuyela kwi maximum. Masina maximum siyakwazi ukuya ku RMS. The same way that we calculated VRMS, the relationship is the same thing, the same that you have for the current as well as the voltage. So for a current, it will be the same thing. siyakuthi I-RMS is equal to I-max over square root of 2. Right? So in our example, njengoba sifuna a maximum value, sizothi I-max will now be I-RMS times square root of 2. So in our example, it's over 0.35 times square root of 2. Then a calculator is osniga 0.35 times square root of 2, 0.49. So total current kabani 0.49 amps. So makumele ke sidwebe igraph efana naleyo voltage. It will be similar to this one, but this one sikhuluma ngani nge-current. So soyidweba kanje the same way, but i-maximum value sisebenzisa bani 0.49. That is the maximum value. So kwi-exam sometimes bakunika nje i-graph engine, then they give you a diagram like this, calculate the maximum current. Right? So into fanele uyenze, don't use i-maximum masusebenzisa i-resistance. Fanele usebenzise bani u-RMS value. Ilento sihlezi sibona ngisho naka Eskom noma endlini kwi device, any electric device, leyo value ubona ukuthi kubhalwe u220 volt, it's a VRMS, it's not a maximum value. Right? Uzobona ke most of ama appliances endlini kuthiwa voltage hlambe 230 volt. Right? Mase uzobona ke symbol ethi kanje kusho ukuthi it is an alternating current. So 230 volt. Lento ibonayo, it is the VRMS. Kusho ukuthi Eskom wona sendela bani uVmax. Right? So uVRMS iwona uzomsebenzisa for ama calculations akho wonke afana nase Ohm's law. V230 RMS values. Masifuna a maximum value, same thing, we said there's a relationship with VRMS uti times square root of 2. Right? Mangdinga VRMS ngizowenza Vmax over square root of 2. Same thing applies for the current. When I need Imax, I just say IRMS times square root of 2. When I have maximum RMS value, I just take the Imax, I divide by square root of 2. So more than calculations with any electric circuit that involves an alternating current, always use VRMS and IRMS. So in a power yako, there will be an average power. It will be VRMS times IRMS. Right? So when zaganjalo ama calculations yako afana exactly na Ohm's law. Right? Just that with Ohm's law, you know that the voltage is steady. Mark 12 volt is just 12 volt. That is the maximum value on high. But here, the maximum value happens just once in a while. So kia change from 0 to maximum, a from maximum to 0, from 0 to minimum, and so on. So that is the alternating current. So we are wazige whether any calculations that is given. Right, the next thing fanesubu ukuthi ama generator must keep AC. What is important? What is the advantage of having an AC generator than a DC generator? Or what is the advantage of an alternating current over a direct current? DC stand for direct current. Right? Now, we have few advantages of AC over DC. The first one, AC can be stepped up or stepped down. Right? Advantages of AC over DC. Right? Advantages of AC over DC. Right? The first thing, AC can be stepped up or step down. Right? Now, this one usebenzisa into esibiza ngani nge transformer. So uyakwazi ukumove ahlambe 230 volt umehlise abe bani abo 5 volt ngoba ku alternating current, right? So this happens kuma chargers again, for example Tomiovi or cell phone charger angisuyiplaga kuyiplug kubuya bani 230 volt, but i-battery yakho inobani 5 volt. So by the time you plug i-charger yakho ya-convert iyayehlisa leyo 230 to bani to 5 volt. That is the advantage yani AC. Kodwa kuyazi ukuthi i-battery yakho isebenzisa DC, so kuzoba khona bani another device is a converter AC into DC, right? So you have you can easily convert, right? Easily convert AC into AC into DC. But kuyenzeka futhi ube na mani convert DC into AC. Kodwa kulula ke mawenza from AC to DC. The next advantage ukuthi when you have an AC uyakwazi kuba ne-transmission and without having what, a lot of losses. So uyakwazi ukusebenzisa for long distance transmission, right? So when we see those poles Eskom long distance, it's because there is what, AC, and with that one there will be just what, a very low energy lost mawusebenzisa AC. So that is the main thing ekumele sikhulume ngayo in terms of electrodynamics, right? So I think for now sesi understand ukuthi just to wrap up, we have two types of electric machines. There will be a generator or a motor, but beside that you can also have two types of motor, a DC or an AC, and you can also have two types of generators, can be DC or AC. Then uyakwazi futhi kuhlukanisa. How do you see that a machine is a motor? Ubona ngokuthi kune battery connected to that machine. So i-battery kipela ikunika bani electrical energy. So i-motor siyazi ukuthi i-converter electrical energy to mechanical energy. But a generator will convert mechanical energy into electrical energy. The principle used for a motor is motor effects, and the principle used for a generator is electromagnetic induction, right? So those are the few things that you need to remember every time. But mese umona kanjani ukuthi this one is a generator. I-generator ubona ngokuthi khona globe noma khona voltmeter noma ammeter, anything esebenzisa ugesi, then you know this one is a generator. The next thing sikhuluma nge-AC or DC, right? So umona kanjani if it's a DC, ubuka ngokuthi khona split ring commutator, right? So it's like a ring that is divided into two, something like this. Then it is a split, right? Split ring, right? Commutator. This is a commutator. Then you know it is a DC. For an AC, an AC, you see what? Two rings. There's a ring, there is another ring. Then sinani ama slip rings, right? Now each generator noma umshini uconnecta kanjani to the external circuit, bakniga ini ama brush. So there will be a brush here, there is also another brush. You have two brushes. Now we AC, then we'll have one brush on one ring, the other brush on the other ring. The next thing with DC, you also need to know the shape of the graph. The graph on a DC imanganje, but the graph on AC, it is an alternating graph. Alternating current. So it is an alternating graph. Right? So that is the key things that you need to know, especially energy conversion. Then we define the machine with in motor or in generator. a motor or definer in terms of energy conversion. State the energy conversion that takes place in the following machine, right? So we had like the pictures here, right? So mhlawumbe kule mase kuthiwa state the energy conversion that will be in this machine. Angithi uyabona ke la ngiyabona ukuthi AC, but angazi ukuthi it's a motor noma a generator. So into ezongitshela ukuthi it's a motor, a generator, ngizobona ukuthi there is a light bulb. Uma sekufaka nje iglobe la, then ngiyazi this one is a generator. Right, so energy conversion, it converter mechanical energy into electrical energy. So this is an AC generator. Ngibona kanjani ukuthi AC? Ngibona ama ring awu2. Right, we call them the slip rings. Ngibona kanjani ukuthi generator ngoba ngibona bani light bulb, right? Noma ngibona ammeter noma voltmeter, then I know it is an AC generator. If I look at this one, right, split ring, so I know this is a DC machine, right? It's a DC machine. Angazi noma it's a motor noma a generator. It will always depend on what is the input, right? So mangibona mhlambe kune battery lana kufaka nje battery like this, then I know because of this battery, then this becomes what? A motor, simply because ithatha le energy, electrical energy, it converter into motion, and that becomes what? The mechanical energy. So you just need to know all those energy conversion. So I see that this one is a DC motor. Mangifuna ukuyenza ibe is DC generator, valeni nginyakazise le conductor, or I rotate it, then lana ngizofaka bani voltmeter and all ammeter and so on, right, until I get it correct, right? So those are the few things we electrodynamics, but we'll always have calculations. Don't forget about the VRMS and the IRMS, or also to how to calculate the power of the generator, normal the power of that is dissipated in the resistance. Angithi kule example yethu sikhulume ngokuthi sine energy, sine voltage ka 08,49, kodwa from graph basinike bani u12 volt. Asiwusebenzisa u12 volt masenza ama calculations. This is the maximum value. Sisebenzisa bani RMS, the root mean square, right? And we define it as the AC value. Makutiwa define RMS voltage, so it's gonna be the AC voltage that will dissipate the same energy as the DC. Makutiwa define RMS current is the AC current that will dissipate the same energy as the DC, right? Makutiwa define RMS value, then uzoti is the AC value. So kia depend ukuthi umbuzo uthini. Now on 24, Masokutiwa calculate what is the power dissipated in this resistor here. So I have many formula for power. So ngingasebenzisa P manje sithiwa sitheni masikhuluma nge-AC sisebenzisa i-average. So i-formula yokuqala ukuthi VRMS times IRMS, right? Noma ngasebenzisa le formula ethi V squared, but ufanele kube VRMS squared over R. Now RMS ngithola ukuthi 8,49, so I can use it to get the power into this this resistor, right? So briefly kumele sazi lokho, and these questions to be toward the end of your question paper. Kuseli topic eyodwa esoyenza next week, that will be the photoelectric effect. Siyabonga abafundi, asibonane ke next week, same place, same time.
Siyathemba nifunde kahle nasithokozela isifundo sethu sanamhlanje enisethulelwe ngezilokotho ezinhle Ithala libambisene neGo Digital SA Foundation. Thamelani ke futhi esilandelayo ngesikhathi sifanayo, ningakhohlwa ukumema nabanye abafundi bebanga le-12 ukuze nabo basizakale kulolu hlelo. Uma ninemibuzo noma nifisa ukuxhumana nathi, ningasithinta ngokufaka imibuzo yenu kwinombolo yethu ye-WhatsApp ethi 068 151 1072. Mfundi, ungakhohlwa ukubhala isifundo obuza ngaso ngaphambi kokubhala umbuzo wakho. Angiyiphinde inamba yethu 068 151 1072. Siyabonga.